Hello everyone. In this video I am going to teach you how to implement doubly linked list, and also I'll teach you how to create and display all the elements present in the doubly linked list. See. Now previously I have taught you singular linked list. What is singular linked list? The structure, these are the nodes, first node, second node, third node, fourth node. In singular linked list, each node, the structure of each node is that each node contains two parts. First part is data part. In that you can store the data value, and other part is pointer part, which stores the address of next node. But here see, in doubly linked list there are the structure of each node contains three parts. In singular you have two parts, in doubly linked list you have three parts. Now let's see what are the parts. See, this is the first part. First part is previous pointer. This previous pointer is used to store the address of previous node. Now see, the address of this node is 100. So 100 is stored here. So it creates a link like this in backward direction. Now this middle part is known as data part. This data part is used to store the data value in that node. Suppose you want to store 5 in this node. So you can store here. Now this third part is called next pointer part. This pointer is used to store the address of next node. So the address of this node is 400. So 400 is stored here. So here the link is created in forward direction. So see here. Now what is doubly linked list? See, there are two links. In singular there is only one link in forward direction, but here there are two links, that is in forward and backward direction. So this is called doubly linked list. And see, this is the head pointer, which is used to point towards the first node. The address of first node is 100, so here 100 is stored. Now see, now I will teach you how to create a doubly linked list. See, now this linked list is empty. That is, there are no nodes present in the linked list. Then if no nodes are present in the linked list, head pointer will have 0 value, because head is a pointer which stores the address of first node, but no node is there, so it is 0. Now see, now you should create a first node. Now I am creating that new node. See here, this is a new node. Now I should access this new node. How I can access? By using a pointer. So I am creating a pointer called new node. See here, this is a pointer called new node, and this is used to point this node. Now let's say the address of this node is 100. Now so this new node pointer stores the address 100. So this pointer points towards this thing. Now see, now you have created a new node. Now I'll create one more pointer called temp. I'll say you afterwards why I am creating it. See, I am creating a pointer temp. Now see, now I have created a new node. Now what is the structure of this node? That is, it contains three parts. First is previous pointer, which stores the address of previous node. Then this middle is data part, which stores the data value, and this is the next pointer, which stores the address of next node. So I want to write the code for defining the structure of the node. So I am writing the code. See here. Now void main. Now this is the main function which computer reads first. Now see, now I am defining the structure of node. Struct node. Now inside the structure, the middle part is data part, and the data value which you are storing here is integer. So I am writing a C. Int data. This int is integer. Now see, now this is pointer part. This first part is called pointer part. Now in this pointer part you are storing the address of previous node. So I am writing a C. I am naming that pointer as previous. You can name it as anything. I am naming it as previous. Now see, pointer previous. Now this pointer is, I'll write here struct node. Why I am writing the struct node, I'll say you now. See, now this pointer previous, this previous point, suppose let's say here one node is there, and now suppose like this link is there. Then this node is pointing towards, this pointer is having the address of previous node. So this pointer is pointing to a previous node which is having same structure as this node. So that's why this both structure are same. So this structure is struct node. This node structure is also same as this. So I am writing struct node here. So this is the case. Now see, now third part is that is next node. So next pointer. So I'm writing here, see, pointer next. That is pointing to another node which is having same structure as this thing. So I'm writing struct node. Now I have defined the structure of a node. Now see, now I have three pointers. One is head pointer which is pointing towards the first node, and new node pointer and temp pointer. So I am defining that pointer, see here. Now struct node. Now first pointer is head. So I am writing pointer head, which will point towards a node having structure. So struct node here. Now see, next pointer is new node. So I am writing a new node. Now see, the other pointer is temp. I'll say you afterwards why I am using this temp. See here, pointer temp. Now see, at starting head value is 0 because no nodes are present in the linked list. The linked list is empty. So head value is 0 at starting. So I am writing SC. Head equals to 0. Then I'll write another variable called choice. Int choice. This choice, what is that? I'll say you now. See here. Suppose you are creating one more new node into this linked list. So you will ask the user whether you want to create a new node or not. So that is the choice. If he says yes, means if he says 1 means you want to create, that means the choice is yes. So you should create. If the choice is no, means you should not create. That's why you are writing choice. Now see. Now while choice. Now what is this loop? I'll say afterwards. Now see. Now first thing is the linked list is empty. Doubly linked list is empty. First, so that you have created this new node. How you are creating? You can create this new node dynamically by using malloc function. So see here, I am writing new node equals to struct node star malloc size of node. Now see, this is new node I have created dynamically by using malloc function. Now this size of node is this thing. Now it takes 12 bytes because this is first part is 4 bytes because it stores integer, that is pointer of previous node. Now this is data part that stores 4 bytes. Then this is also a pointer which stores 4 bytes. So 3 times 4, that means 12 bytes. So that is the size of node. Now see, I have created this new node. Now what I should do? Now see. Now next step is I should ask the user what data he want to insert into this node in the middle part, that is the data part. So see, I am writing the statement print f enter data. So it gives the statement enter data. It asks the user to enter the data. Suppose let's say the computer is asking enter data. So the user says 7. So 7 should get stored into this data part. So how to store? That's why I'm writing the statement. See here, scanf statement. Scanf %d wait, and new node data. Now see, now you have entered 7. Now that 7 is %d. Now what is that 7? 7 is new node data. The scanf statement is used to read that 7. Now 7 is stored as new node data. New node is 100. 100's data is this middle part. So here 7 gets stored. Now see, now next step is you should in this previous pointer you should store 0 because no node is present before this. So that's why I'm writing, see here, new node previous equals to 0. How you can access this pointer? By using new node pointer. New node previous is here, that you should set as 0. So that means no node is present before this. Now see, next step is you should put 0 in the next pointer of this node. So that means no node is present after this because you are inserting this node as the first node. So see here, I am writing new node next equals to 0. Now I have written 0. Now see, now I should check. Now see, at starting, now the linked list is empty. No node is present. This is the node which you are inserting, creating first. So see here, now head is 0 because the linked list is empty. So I am writing the code. See here, if head equals to 0, if head is 0 means means no node is present in the linked list. Now what you should make? Now you should set this as the first node of the linked list. How you can set it? You should create this pointer, head pointer should point towards this node. Now how you can point? So you should store the address of this new node into this head pointer. So address of new node is 100. So you should store 100 over here. So this pointer points over here. So you should write head equals to new node. Head is 0 before. Now you should update that head. New node address is 100. So head is 100. So you created a link. So that's what I'm writing here. See. Now in that again temp variable is there, right? Temp also you should point towards this new node. So temp should be equals to new node. New node address is 100. So temp is 100. So it creates a pointer which points towards the first node. So I'm writing the code here. See here. Head equals to temp equals to new node. I have created. Now see. Now next condition else. Now see. Suppose now in this case. Now you have inserted first element. Now the linked list is not empty. So check. See if head is 0. No, head is not 0. It's 100. That means one element is already present in the linked list. Then what you should do? Then it goes back. It creates a new linked list, new node, and a pointer called new node. This new node pointer points towards this node. Let's say the address of this node is 200. So this stores 200 and this points over here. Now see. Now it creates a new node by using this malloc function. Then then the data values enter data. So let's say the user says 9. So 9 is stored here. Then new node previous is 0, previous pointer is 0 and next pointer is 0. So here both are 0. Now see. Now you should fix this as the second node. How you can fix? See here. Now you should create a link like this in forward direction. How you can create? How for that you should in this next pointer of previous node, this node, you should store here the address of this node 200. If you store 200, you can create a forward link. So how you can access this next pointer? So that's I see here. Now this is 0. Now for this accessing this pointer, you are using a temp pointer. Temp next. So I'm writing a see here. Temp next. This temp next should be equals to the address of new node. New node is 200. So I'm writing 200 here. Then it creates a forward link. So temp next equals to new node. This statement. Now see. Now I'm writing new node previous equals to temp. What is the statement? See here. Now you should create a backward link because this is a doubly linked list. So how you can create? See, this is the previous pointer of this node. Now in this previous pointer you should store the address of previous node, that is 100. So how you can store? See, that's why I'm writing new node previous. New node is 200. 200 previous is this part, pointer part. Now in that part you should store the temp pointer. Now temp is 100. So I'm storing 100 over here. Now I stored 100. That means it creates a backward link which is pointing towards the node 100. So I created a to link. This is how you should create. Now see, after creating, you should move the temp pointer to the next node. Now see, I am writing the code. Temp equals to new node. See how you are moving this. No, see, Yeah, now temp is 100. Now instead of this you should update the temp value. New node is 200. So I'm writing here 200. Temp equals to this 200. So this pointer gets cancelled and it points towards this thing, this node. Now see, now I have moved this thing. This is how you create a doubly linked list. Now see, you may think why I have created this temp pointer to access this pointer. I can use head pointer, right? See here, suppose head next. If I write head next, see here, head is pointing towards the 100 node, address 100. So 100 next is what? 100 next is this part, this pointer part. You can access the next pointer of this node using head, right? Why you are using temp? See here, because now in this step your temp was starting at first node. At initially temp was pointing at first node. Then you have moved the temp pointer to the next node after creating new node. You have moved the temp, but that's why I am creating a temp pointer. You can't move the head pointer. Head is because head is a pointer which points only the first node. It is used to point the address of first node. It can't point towards the second node. So head pointer can't move forward. So that's why I'm creating an extra pointer called temp, which is used for moving. That's why I'm creating. Now see, I have done. Now see, now the next step is you should ask the user whether you want to create a new node or not. See, suppose I'm creating a new node. That means I want to ask the user whether he want to create. So I am writing the statement. See here, print f, do you want to continue? In bracket I am writing 0, 1. Now what is this? You are asking the user whether he want to create a new node or not. There are two options, there are two choices. That is why I am writing here temp variable choice. See, no, I am creating a variable called choice. He enters his choice 0 or 1. 0 means he doesn't want to create. 1 means he wants to create. So that 0 or 1 is a choice. So I am writing here, see, scanf %d comma and choice. Now the value which he enters 0 or 1 is considered as choice. Now see, this is how, now after he enters, suppose he enters 1, that means he wants to create a linked list. Then see, it goes back and it enters this loop while choice equals to 1. Then it enters into this code. It creates a new node and it asks the user to enter data. Suppose let's say 11, then 11 is put here, then 0 will be put here, and next to backward link and forward link will be created. And this stores the address of previous node 200. Then this stores the address of this node. Let's say the address is 300. So it stores here 300. This step will follow. Now suppose if he enters 0, that means it does not enter into this condition. That is, it does not create a new node. This is how you should create a new node in a doubly linked list. See, now I will teach you how to display all the elements present in the linked list. See, now there are this is the doubly linked list and there are 4 nodes. This is first node, second node, third node, fourth node. Now you should display the elements present in this nodes. So the data present in first node is 7. So 7 should be printed, then 9, then 11, then 13. You should display these elements. How you should display? See that, let's see. For that you should create a pointer called temp. Now that pointer temp should point towards the first node. So you should store the address of head. Head is 100 because head is only points towards the first node. So temp should be equals to the head. Head is 100. So temp will be 100. Then this pointer points towards the first node. Now next step is you should print the data present in this node, in the temp node. Now temp is having address 100. 100 data is 7. So 7 gets printed. Then what you should do? You should move the temp pointer to the next node. So how you can move? You should store the address of 200 over here. How you can access this address? You should write temp equals to temp next. So temp is 100. 100 next is 200. So you should write 200 here. If you write, then the pointer points towards the node having address 200. Now Again you should go back and do the same step. You should print the data present in this address. Now temp is having address 200. 200 data is 9. So 9 gets printed. Then temp pointer moves one step forward. So temp equals to temp next. So 200 is temp. 200 next is 300. So I'll update this value to 300. So now this pointer is used to point to the node having address 300. Now again print the data present in this address. Temp is 300. 300 data is 11. So print it. Now again move the temp to one step forward. So temp equals to temp next. So 300 is temp. 300 next is 400. So update it to 400. So you will move this pointer to the next node having address 400. Now again print the data present in this temp address. Temp address is 400. 400 data is 13. So you will print 13. Now you should move the temp variable temp pointer one step forward. So temp equals to temp next. Temp is 400. 400 next is 0. So update it to 0. Now this pointer points towards next node. But see here no node is present after this node having address 400. No node is present. So you should stop. Now see you have displayed all elements. This is how you should display all the elements present in this doubly linked list. Now let's write the code. See here. First you have created a pointer called temp at starting which was pointing at first node. So I am creating, see here, pointer temp, that is struct node. This pointer temp is pointing to a node which is having structure node. Now this pointer is pointing towards the first node at starting. So how you can access first node? By using head, because head stores the address 100, that is first node. So see here, temp equals to head. I have created a pointer and I have pointed it to first node. Now see, now next step is, see, print f %d comma temp data. Now in this step I have printed the data present in this address temp. Temp address is 100. Now 100's data is 7. So 7 gets printed. Then what I did? Then I moved this temp pointer towards the next node. How I have moved? I have written here instead of 100, I have updated it to 200. How I got 200? Now I have updated the, see here, temp equals to temp next. By this formula I have updated. See, temp was 100 before. I have changed it to temp next. 100 it was before. So 100's next is 200. So I have updated it to 200, then it pointed here. So this is the step which you should do. Now again you should go back. See here. Now you are in second node. Now again you should do the first statement. Print the data present in this node. So you should print the data 9. Then you should move towards this step. Temp equals to temp next. So temp is 200. 200 next is 300. So you will point it to this node. Then again you will print the data 11. You will go back and print 11 and move the pointer to 400. So this node will move to 400 like this. Till how much you should move? Till, see, now you are in temp is 400. Now 400 next is 0. So you are moving it to 0. See, now you should stop. Now you should stop the printing and moving it. You should stop it. So when you should stop? When temp value is 0. So I am writing that condition. While temp not equals to 0. What is this? See here. Now temp is 0. So I am checking this condition. Whether temp is not equals to 0. No, temp is 0. That means it does not enter here. It does not print. So it prints till when temp was 400. When temp value was 400, till that it displays. So it prints 13. Till 13 it displays. So this is how you should display all the elements present in the doubly linked list, and this is how you should write the code. That's all for today, and thank you. If you feel my teaching is good, then like my video, and if you have any doubts or if you want to give any suggestion, then comment on my video and share my video, and don't forget to subscribe my video. Thank you.